So far in our study of matter, we've explored what matter is, different types of states or phases, and different ways that it can be classified. Today, we're going to explore physical and chemical properties of matter. These are characteristics that they have. So, like when we talked about groups or families in the periodic table, and we said the same group or family has the same characteristics, they share qualities with one another. These are some of those characteristics or properties that we're talking about. Now, we can use these physical and chemical properties to identify matter. And so if we have something we don't know what it is, we can use the properties or the characteristics to figure out what it is. We can describe it, we can classify it. And so it gives us a lot of good resources to be able to use and figure out what that particular piece of matter is, or put it in the right place. Physical properties of matter are characteristics that can be observed or measured without changing a substance into something else. And so this is a physical, what you can see, what you can touch, what you can smell, those kind of things. It doesn't change it into any other kind of substance. So phase changes, for example, would be physical properties or physical changes, that it may change from a solid to a liquid, but it still stays the same substance. And so some of those properties that we're going to be looking at for physical properties include shape, odor, color, density, solubility, and melting point. So shape, odor, and color, pretty self-explanatory. You probably already know what those mean. So we're not going to go into a great deal of detail on those, but we are going to look at those last three: density, solubility, and melting point. Density is the amount of matter in a given space. So it's very similar in wording to the definition of mass, but it is a little bit different. Density is the amount of matter in a given space. This information can be used to help identify and describe a substance. For example, if you have a baseball in one hand and a styrofoam ball of the same size in the other, you'll notice that both take up the same amount of space or have the same volume. The baseball, though, is more dense than the styrofoam ball because it contains more matter in the same amount of space. So the same would be true of a 1 centimeter cube of sugar versus a 1 centimeter cube of silver. Whichever one has more matter or mass in that same amount of space is going to have more density. So it's important to notice, as we identify and describe these substances, equal volumes of different substances usually have different masses and thus different densities. The density of a specific type of matter will always be the same. So whether you have 1 cup of water or 1 gallon of water, the density of that water is going to be the same. Density also determines buoyancy of a substance. Buoyancy is the ability of a substance to rise up or float in a fluid. And so if you have an object that has less density than water, for example, it's going to float. If it has more density than water, it's going to sink. So paper would float, a rock would sink. The way that we figure out density mathematically is density equals mass divided by volume. So how much matter there is divided by how much space it's taken up. Another method that we use to find density is we can place it into a liquid of a known substance or a known density and see, does it float or does it sink? And that gives us an idea as well of how dense that particular object is. The next thing we're going to look at is solubility. Solubility is the ability of a substance to be dissolved. So when a substance dissolves, its particles separate and spread out evenly to form a special kind of mixture called a solution. And so we've looked at different mixtures, and even on the homework that you had the other day, that I told you 2 of those words we hadn't really talked about. You had homogeneous and heterogeneous. And so a homogeneous mixture is one that's the same throughout. That's going to be this solution that you're dealing with. They spread out evenly to form a solution. Like density, solubility is a characteristic of a substance regardless of the size of the sample. And so whether it's 1 cup or 1 gallon, it's going to be the same as far as its solubility. A couple other words that go along with this. Well, if you want to test the solubility of a substance, that substance is called the solute. A solute is the substance that is dissolved. So this would be like sugar. So if you want to test that solubility, you place it in another substance called the solvent. The solvent's the substance doing the dissolving, like water. And so you could take something and put it in water, stir it up, see, does it dissolve in that? Another thing that we're going to see is that temperature affects solubility. And so you kind of saw this when we did the food coloring in the room temperature beaker and the food coloring in the hot beaker. And so you saw how it dissolved quicker in the hot one. We'll see how that works with solids as well. The solubility of a specific substance, like I said, will always be the same. And so that helps us identify what that substance is. We're going to look at melting point. Melting point is the specific temperature at which a substance changes from a solid phase to a state or phase or state into a liquid phase or state. So different substances have different melting points. Metal has a higher melting point than ice does. So we're able to identify different elements based on when they melt. Melting point can be used to identify unknown substances. Next, we're going to talk about chemical properties. Chemical properties of matter tell us whether the substance can undergo a chemical change. And so it's a substance where things actually change into a new substance. Some of those that we're going to look at are acidity, basicity, combustibility, and reactivity. So when a chemical change takes place, a new substance is created. In a physical change, it doesn't change what the substance is. It just changes one of the characteristics. In a chemical change, a new substance is created. So chemical properties are going to see what happens when that new substance is being created or how they react and interact with other things around them. Acidity and basicity are two chemical properties that help scientists identify matter. And so simple definitions, it seems kind of silly, but acidity is just the state of being an acid. And so if an element is an acid, it has acidity. If it's a base, it has basicity. And so while acidity is the state of being an acid, basicity is the state of being a base. We use a pH scale to measure the acidity and the basicity of a substance. On this scale, it's a scale of 14. Readings lower than 7 are considered acidic. As the number decreases, the acidity of the substance increases. Readings greater than 7 are considered to be basic. As the numbers increase, the basicity of the substance increases. Next, we're going to look at combustibility and reactivity. Combustibility is the measure of a substance's ability to ignite or burn. And reactivity is the measure of how easily a substance will react chemically with another substance. Both of these can be used to identify matter because all matter kind of reacts uniquely or combust uniquely. And so when you take combustibility, reactivity, acidity, basicity, melting point, all these different characteristics, and you can start to narrow down what it is that this substance is. If a substance does not burn, it's described as non-combustible. For example, if a flame is brought close to gasoline, the gasoline vapors will ignite and burn, so it's combustible. But water is not combustible and can be used even to put out fires, as you know. Reactivity measures that's how strongly a substance reacts with another kind of matter. For example, iron reacts with oxygen to produce rust, and so it's reactive. Alka-Seltzer tablets, citric acid and sodium bicarbonate, they react with water to produce water and carbon dioxide. And so scientists can use those different reactions to see how do these chemicals interact with one another. And so that's the ways that we use these different chemical and physical properties to identify matter. We're going to be doing some labs and identifying unknown elements or unknown compounds by how they react with one another, how they combust, how are they acid, are they basic, how do they those physical properties, how do they melt? And so we'll be using that as a means to figure out what it is